and we know that this is not real, so this is a severe artifact in diffusion-weighted imaging. Also, susceptibility artifacts are really severe in spinal cord, especially it is worse in spinal cord actually, because in spinal cord there are some tiny susceptibility variations in even smallest possible regions as well. You can see the B0 web here. The lines here show the different magnetization features or different susceptibilities. Okay, so as an example, this is the TP-weighted image. This is the full field of view diffusion-weighted image of spinal cord. So you can see that the spinal cord is like elongated in right from left to right, which is an artifact, which is not real. We know this. So to overcome this issue, methods such as reduced field of view imaging can be used, and this is the corrected image. So what are the common pulse sequences used in the diffusion-weighted images? Okay, so spin echo and stimulated spin echo based diffusion-weighted image diffusion weighting, let's say, these are the first pulse sequences that was used in DWI. That's why I put them here. But nowadays, those are not used since the acquisition times are really low. So that's why I'm not going to talk about them. The most common pulse sequences are today are single shot echoplanar imaging and multi-shot echoplanar imaging. There are also some others like line scan imaging, but I'm not going to talk about them. Okay, so in single shot echoplanar imaging, the pulse sequence can be seen here, and in this pulse sequence, the K space is traversed in such a way that in only one repetition time. So you start, for example, from here, and then in one TR you quickly traverse the whole K space. So that's why the resolution is really bad due to T2 star decay, because we have to acquire the whole K space in only one repetition time. Also this method has really bad signal to noise ratio. So in order to attain a reasonable SNR, multiple acquisitions have to be averaged. Also, single shot echoplanar imaging is not appropriate for susceptibility variations, because it gets affected by high susceptibility artifacts. So here you can see the multi-shot echoplanar imaging. So here we are traversing the K space in multiple interleaves, or multiple shots, we can say. For example, this can be thought as a single shot EPI done multiple times in one slice. For example, here we are at this point with the blue solid line. In one TR we acquired the blue solid line, and in other TR we acquired the dashed solid line, and for example in the third TR we acquired the dotted solid line here, so that we can have a more reasonable resolution and SNR. However, as I mentioned before, there are some inevitable motion in our body, such as CSF pulsation or heart pulsation. So some motion in the body has to occur. So that's why the K space is shifted between the interleaves. So that's why navigator echoes have to be used to correct for the motion. Okay, and multi-shot echoplanar imaging also has lower susceptibility artifacts when compared to single shot echo period imaging. So you can see a comparison of SS EPI and multi-shot EPI here. These are actually the apparent diffusion coefficient maps. The diffusion coefficient maps can be found by leaving the D alone in the signal equation. So here in A, multi-shot apparent diffusion coefficient map without any artifacts, for example, but in B, this is the single shot version of it. So here you can, in frontal lobe, you can see some distortions. So this is really not something that we want. But both A and B are corrected in terms of their problems. For example, C is also multi-shot imaging, multi-shot EPI, and here you can see some darker regions, and these darker regions are due to the motion artifacts. So navigator echoes are sometimes not adequate enough to correct for the motion. Also in single shot EPI you can see some ghost artifacts like this. So both of them has their own advantage and disadvantages. So here are my references. Thank you for listening.